Hello everyone, my name is Keshav Mishra and this is the testing tool presentation for CSE 755, Software Testing and Quality Assurance. The testing tool I will be presenting today is called Postman. This presentation is divided into 12 parts. Part 1 is a quick introduction along with the learning objectives. In Part 2, I will briefly talk about what API testing is. In Part 3, I'll show you the Postman interface and some of its core concepts. Then I'll walk you through sending your first API request, followed by understanding and validating the response. Then in Part 6, we'll go over writing automated tests and learning about variables and environments in Postman. Next, in Part 8, we'll go over collections, which is a central concept in organizing the test suite in Postman. In Part 9, we'll talk about advanced API testing and cover topics such as chaining, test data, and automated execution. And then finally, Part 10 will be a quick recap of what we have learned so far today. So let's dive into Part 1, which is a quick introduction and the learning objectives. So today we are going to look at API testing using Postman. The goal of this presentation is not to spend a lot of time discussing the theory behind APIs. Instead, we're going to focus on actually using Postman and building API tests step by step. We'll start with something very simple, sending an API request and looking at the response. From there, we'll move into testing. We'll see how we can automatically verify that an API returns the correct status code, the expected data, and acceptable response times. Then we'll introduce variables and environments, which allows us to make our tests more reusable. We'll organize our requests into collections, connect multiple requests together, and finally look at how we can run those tests automatically using the collection runner and Newman. By the end, you should have a basic understanding of how Postman can take us from manually testing one API request to building an automated API testing workflow. So let's start with just a little bit of background on what we're actually testing. Moving on to part 2, what is API testing? Before we open Postman, let's quickly establish what API testing actually means. An API, or application programming interface, allows different software components to communicate with each other. They are the backbone of modern software. For example, imagine we have a web application that needs information about a user. The application might send a GET request to an API asking for user number 1. The API processes that request and sends a response back, usually containing a status code and some data, often in JSON format. API testing is the process of checking whether that interaction works correctly. We're interested in questions like, did the API return the correct status code? Did we receive the data we expected? Was the response formatted correctly? Did the API respond within an acceptable amount of time? And what happens when we send invalid data? Postman gives us a convenient interface for sending these requests and checking the results. So rather than building our own application just to test an API, we can use Postman to interact with the API directly. API testing is non-negotiable, and it verifies that the API behaves as expected. So just to provide a brief overview of the API testing workflow, there are 5 key processes involved in the API testing workflow. Step 1 is sending requests. Step 2 is inspecting the response. Step 3 is validating the response. Next is organizing tests. And finally, automating the execution of the test. Moving on to part 3, Postman interface and core concepts. So now that we've briefly discussed what API testing is, let's move into Postman itself. Postman is very easy to download and install. It can be downloaded from the URL mentioned here, postman.com/downloads. It is also available for Mac and Linux operating systems. Here is the landing page of the Postman desktop application. There are quite a few features available in Postman, but we're going to focus on the features that are most relevant to API testing. As you'll notice here on the left, beneath the Home option in the sidebar, we have Workspaces. A workspace is essentially an area where we can organize our API development and testing work. Depending on how a team uses Postman, we might have different workspaces for different projects or teams. For today's demonstration, I'm going to work within a single workspace. Here's a quick demonstration of how to create a workspace in Postman. Simply navigate to the workspace option in the sidebar, assign an appropriate name and configure some other settings, and click on Create Workspace. Once you've created a workspace, this is what you'll see. On the left-hand side, we have our navigation area. This is where we can access things like collections, environments, and other Postman resources. So let's start with collections. A collection is essentially a group of related API requests. For example, if I'm testing an application that has user-related APIs, I might have a collection called User API Tests. That collection could contain requests for getting users, creating users, updating users, and deleting users. We'll come back to collections later, but for now, just think of a collection as a way to organize related requests. Now that we have created a workspace, we'll first create a collection within our workspace and then a request within that collection. At the top of the request window, we have our HTTP method. The method tells the API what type of operation we're trying to perform. The most common methods we'll work with are get, post, put, patch, and delete. Get is typically used to retrieve information. Post is commonly used to create a new resource. Put and patch are used to update existing resources. And delete is used to remove a resource. Next, we have the URL field. This is where we specify the endpoint that we want to communicate with. For example, an API might have an endpoint that looks something like this in our example. This tells us that we're making a request to the user's endpoint, and we are asking for user with the name variable as name. Below the URL, we have several tabs. The params tab is used for query parameters. Query parameters are values that we can append to our URL to modify the request. For example, we might use a parameter to limit the number of results returned by an API. In our example here, we use the parameter name to define the user's name. Next, we have the authorization tab, where we configure authentication when an API requires us to prove who we are. For example, an API might require a bearer token or an API key. The Headers tab allows us to provide additional information about a request. For example, we might specify that we're sending JSON data by setting the content type header. The Body tab is where we can provide data to the server. This is particularly important for post, put, and patch requests. For example, if we're trying to create a new user, we might send the user's name and email address in the request body. Finally, we have the scripts area. This is where we can write JavaScript code that runs before or after a request. For API testing, we'll primarily be interested in writing tests that run after the API sends us the response. We'll use those tests to automatically verify that the API behaved as expected. Down here, we have the response. After we send a request, the response appears in the lower part of the screen. This is where we can inspect the status code, response body, headers, cookies, and response time. So at a high level, the workflow we're going to follow today is we create a request, we configure the request, we send it to the API, we inspect the response, and then we write automated tests to determine whether that response is correct. Now that we have seen where everything is, let's actually send our first API request. Now I'll show you how to send your first API request. Let's start with the simplest possible example. I'm going to use JSON placeholder for today's demonstration. JSON placeholder is a free fake REST API that provides sample data and is useful for learning and testing. The advantage of using a public API like this for a demonstration is that we don't need to spend time setting up a backend application or configuring authentication. So let's start with a GET request. I'll select GET from the HTTP method dropdown. Now I'm going to enter the endpoint for a specific user. Now I'll click Send. Immediately, we can see the response from the API. Let's look at what Postman is showing us. First, we have the status code. Here, we received 200 OK. A 200 status code indicates that the request was successfully processed. Next, we have the response body. The response body contains information about the user. We can see things like the user's ID, name, username, email, and address. Notice that the response is formatted as JSON. JSON is one of the most common data formats used by modern APIs. Next, we can look at the response headers. Headers provide metadata about the response. For example, we might see information about the content type, caching, server, or other details. Finally, we have the response time. This tells us how long the API took to respond to our request. Response time can be important when testing an API because an API that technically works but takes an extremely long time to respond may still be considered problematic. Now let's look at the query parameters. Instead of requesting a single user, let's request multiple users. I'll change our endpoint to /users. Now when I send the request, we get a list of users. Let's say we only want 5 users. I could manually add a query parameter to the URL, but Postman gives us a convenient way to do that. I'll click on the Params tab. Here I'll add a limit key and set the value as 5. Notice that Postman automatically updates the URL. Now I'll send the request again. We can see that the API now returns only 5 results. This is a good example of how query parameters can change the behavior of an API request. Now let's look at another HTTP method, POST. I'll change the method from GET to POST. A POST request is commonly used when we want to create a new resource. For example, let's say we want to create a new post. I'll use the /posts endpoint. Unlike our GET request, we're now going to send data to the API. I'll open the Body tab. I'll select raw and then select JSON as the format. And now we'll fill the Body tab with the following information. Now I'll send the request. The API processes the data we sent and returns a response. Notice that the response includes the data we submitted and gives us an ID for the newly created resource. In a real application, that ID would usually correspond to a resource that was actually created in a database. JSON placeholder simulates this behavior for demonstration purposes. So we have now seen how to send requests and inspect responses. But right now we're manually looking at the response and deciding whether it looks correct. Let's talk about how we can validate those responses. Moving on to part 5, understanding and validating responses. Let's pause for a moment and think about what we're actually doing when we test an API. When I send an API request, I receive a response. As a human, I can look at the response and say, yes, this looks correct. But manual inspection doesn't scale. Imagine that we have 100 API endpoints. Now imagine that each endpoint needs to be tested with 10 different inputs. That could easily become thousands of individual test cases. We don't want a tester to manually look at every response. Instead, we want to define our expectations and have the computer automatically verify them. Let's consider the types of things we might want to validate. The first thing is the HTTP status code. For a successful GET request, we might expect a 200 status code. For a successful POST request that creates a resource, we might expect a 201 status code. If the user isn't authenticated, we might expect a 401 status code. If the requested resource doesn't exist, we might expect a 404 status code. And if there is a server-side problem, we might see a 500 level status code. So one of the simplest API tests we can write is, did the API return the status code that we expected? But status codes aren't enough. An API could return a 200 status code and still return incorrect data. For example, imagine we're asking for user number 1. The API could return 200 OK, but accidentally return information about user number 2. From an HTTP perspective, the request was successful. From an application perspective, the API is still wrong. So we also need to validate the response body. We might also have performance expectations. For example, we might decide that an API should respond within 1 second. Postman allows us to test response time as part of our automated tests. Again, this isn't a replacement for dedicated performance testing, but it can help us catch obvious performance regressions. So now let's take these ideas and turn them into actual automated tests inside Postman. Moving on to part 6, writing automated tests in Postman. This is one of the most important sections of today's presentation. We've already sent requests manually. Now we're going to tell Postman what a correct response looks like and let Postman automatically check it for us. Postman allows us to write tests using JavaScript. I'm going to start with a very simple test. For this demonstration, I'm going to use our GET request for a single user. Before we add our test, let's send the request normally. We can see that we received a 200 status code. As a human, we can see that the request was successful. Now let's tell Postman to check this automatically. I'll go to the script section and select the post response script area. This is where we can write JavaScript that executes after Postman receives the API response. Let's break this down. The pm.test function is used to define a test. The first argument is the name of our test. Status code is 200. This is the name that Postman will display in the test results. The second argument is a function containing the actual test. Inside that function, we're accessing the API response through pm.response. We're then checking that the status code is 200. So we're essentially telling Postman, after the request finishes, verify that the API returned a 200 status code. Now I'll save the request and send it again. Now we can see our test result. The request succeeded and our test passed. So we've just converted a manual check into an automated assertion. Sometimes we don't want to test for exactly one status code. For example, depending on the API design, we might expect either a 200 or a 201 response. We can write a test that checks whether the response code is one of several acceptable values. Here, we're using pm.expect to define our expectation. We're checking the response code and saying that it should be either 200 or 201. This is useful when an endpoint may legitimately return more than one successful status code. We can also test for error conditions. For example, if we intentionally send an invalid request, we might expect a 400 status code. The important idea is that we're not only testing successful requests. A good API test suite should also verify that the API handles invalid input correctly. Checking the status code is useful, but it doesn't tell us whether the actual data is correct. Let's imagine that we request user number 1. The API returns a 200 status code, but what if it accidentally returns information about user number 2? Our status code test would still pass. So we also need to validate the response body. I'm going to store the parsed response in a variable called response. Now that we can access individual fields, the response contains an ID field. Let's verify that the ID is actually 1. Now we have two tests. The first checks that the HTTP status code is 200. The second checks that the user ID in the response is actually 1. Let's send the request again. We can now see that both tests pass. We can continue adding assertions to validate different parts of the response. We can check the user's name. We can verify that an email address is included, and so on. Notice the difference between these two types of tests. In the first test, we're checking an exact value. We're saying the user's name should be exactly Leanne Graham. In the second test, we're only checking that an email field exists. We don't necessarily care what the email address is. We're simply verifying that the API returned the expected fields. Another useful validation is checking the data type. APIs have contracts. For example, we might expect the ID to always be a number. We might expect the name to always be a string. We can validate these expectations using Postman. Here, we're checking that the ID is a number. And here we're checking that the name is a string. This can help us catch unexpected changes to the API response structure. We can also test basic performance characteristics. Let's say our requirement is that the API should respond in less than 1 second. We can write a test for that. Here, pm.response.response_time gives us the response time in milliseconds. We are checking that the value is below 1000. If the response takes longer than 1 second, the test will fail. One important point here is that this is not a replacement for dedicated performance or load testing. The response time can vary depending on network conditions and server load. However, this type of assertion can still be useful for identifying obvious performance regressions. Let's put everything we've learned together. For a single API, we can have multiple tests. We can verify the status code, the actual data, the response structure, the data types, and the response time. Now when I send this request, Postman executes all of these tests. We can see the results individually. This gives us more confidence in the API response than simply checking whether we received a 200 status code. Now I want to demonstrate what happens when something goes wrong. I'm going to intentionally change one of our expectations. Instead of expecting the user ID to be 1, I'm going to say that we expect it to be 999. Now I'll send the request again. We can see that the test fails. This is important because the test suite isn't useful if it only tells us when everything is working. We also need it to tell us when something isn't working. Postman gives us information about the failure. We expected the value to be 999, but the API actually returned 1. In a real testing scenario, this failure could indicate several things. Maybe the API has a bug. Maybe our test has an incorrect expectation. Maybe the API contract has changed. The important thing is that the automated test has detected a discrepancy. So at this point, we've taken a basic API request and transformed it into an automated test. We started with a simple status code assertion. Then we added response body validation. We checked fields and data types. We added a response time check. And we saw both passing and failing tests. However, there's still one problem with our current approach. Our API URL and our user ID are hard-coded directly into our request. If we wanted to run the same tests against a development server, a testing server, or a production server, we'd have to manually change our requests. That's not very reusable. In the next section, we'll look at variables and environments and see how Postman allows us to make our API tests much more flexible and reusable. Moving on to part 7, variables and environments. In the previous section, we created automated tests for our API. Our tests are now able to check status codes, response data, data types, and response times. However, if you look closely at our request, there is still a problem. Our API URL is hard-coded directly into the request. For example, we're using JSON placeholder.tipico.com/users/1. This works for our demonstration, but let's imagine we're testing a real application. In a real software project, we might have different environments. We could have a development environment, a testing environment, and a production environment. The API URL might be different in each one. For example, in development, the API URL might look like this. In testing, it may look like this. In production, the API URL might look like this. Imagine that we have 50 API requests in our collection. If the API URL is hard-coded in every request, switching from testing to production means potentially changing the URL in all 50 requests. That's inefficient and introduces the possibility of mistakes. This is where Postman variables become useful. Instead of hard-coding these values, we can store them in variables and reference those variables from our requests. Let's replace our hard-coded API URL with a variable. I'm going to create a variable called base URL. The value of this variable will be jsonplaceholder.typicode.com. Now, instead of writing the full URL directly in our request, we'll simply write curly braces base URL user/users/1. The double curly braces tell Postman that base URL is a variable. When I send the request, Postman replaces base URL with its actual value. The API receives the same URL as before, but our request is now more flexible. Now let's look at where we can define this variable. Postman provides several ways to manage variables. For our purposes today, we're going to focus primarily on environment variables. An environment allows us to store values that are specific to a particular environment. I'm now going to create a new environment called testing. Now I'll add a variable called base URL. And for the value, I'll enter HTTPS jsonplaceholder.typicode.com. Depending on the Postman interface version, you may see both an initial value and a current value. For a simple demonstration like this, we'll use the same value for both. Now I'll select the testing environment from the environment dropdown. And now let's send a request again. The request works exactly as before. The important difference is that the URL is no longer hard-coded into the request. Now that we've moved our base URL into a variable, let's do the same thing with our user ID. Currently, our request looks like this: base URL/user/1. The number 1 is still hard-coded. Let's create another variable called user ID. I'll give it a value of 1. Now we'll update our request. Postman replaces both variables before sending the request. Now let's change the value of user ID from 1 to 2. I haven't changed the request itself. The request still says base URL/user/user ID. But when I send it again, Postman now requests user 2. This demonstrates one of the main benefits of variables. The request is reusable. The actual values can change without changing the request itself. Variables can also be used inside our automated test scripts. This is particularly useful because we don't want our tests to contain hard-coded values either. For example, earlier we had a test that looked like this. The problem is that the expected value is hard-coded as 1. If we change our request to retrieve user 2, our test would still expect user 1. That's not what we want. Here, we're getting the value of user ID from the current environment. The number function converts the value to a number. Then our test compares the ID returned by the API to the expected ID stored in our environment. This means our request and our test are now using the same variable. If we change user ID 1 to user ID 2, the request retrieves user 2, and the test automatically expects user 2. This makes our test much more reusable. Now let's look at the real power of environments. Imagine our application has 3 different environments. We could create a development environment, a testing environment, and a production environment. In the development environment, we might have base URL equals https dev.example.com. In testing, we might have base URL equals test.example.com. And in production, base URL equals api.example.com. Our request itself doesn't change. It still says base URL /user/user ID. If I select the development environment, Postman uses the development URL. If I switch to testing, Postman uses the testing URL. If I switch to production, Postman uses the production URL. This is a major advantage. We can have one collection of requests and use it across multiple environments. We don't need to duplicate our entire test suite for development, testing, and production. Let's put everything together. Our environment might contain variables such as base URL, user ID, and potentially an authentication token. Our request can use these variables. And our test scripts can access environment variables programmatically. Now our entire test workflow is parameterized. This means that the same collection can be used with different values. Now we have reusable requests, dynamic variables, and environment-specific configurations. But as we continue adding API endpoints, we're going to end up with a lot of individual requests. We might have requests for users, products, authentication, orders, and other parts of our application. We need a way to organize all of those requests and tests into a structured test suite. That's where Postman collections come in. In part 8, we look at how we can organize our API requests into collections and folders and eventually run them as a group. At this point, we've created several API requests. We have GET requests, we've created POST requests, we've added automated tests, we've also introduced variables and environments. But as we continue developing our API test suite, we're going to have more and more requests. Imagine that we're testing a large application. We might have requests for users, products, authentication, orders, and payments. If all of our requests are just sitting in one large list, it becomes difficult to find what we're looking for. It's also difficult to run only the tests related to a particular part of our application. This is where Postman collections become useful. A collection is essentially a container for related API requests. For example, I could create a collection called User API Tests. Inside that collection, I could have requests for getting all users, getting a specific user, creating a user, updating a user, and deleting a user. Now these requests are grouped together and can be managed as a single unit. Open the collection section, select new collection, and name it User API Tests. Add the existing requests to the collection. Now that we have a collection, we can organize it even further using folders. A collection can contain folders. Folders are useful when we have a large number of requests and want to organize them logically. For example, I could create a folder called User Retrieval. Inside that folder, I might have Get All Users and Get User. I could create another folder called User Management. That folder might contain Create User, Update User, and Delete User. I could also create a folder for negative tests. Appropriate requests are moved into each folder. One organizational approach that I find particularly useful is separating positive and negative tests. Positive tests use valid inputs and verify that the API behaves correctly. For example, when I request an existing user, I expect a 200 response. Negative tests intentionally use invalid inputs. For example, when I request a user that doesn't exist, I expect a 404 response. This makes it very clear what our test suite is checking. We're not just testing that the API works when everything is correct. We're also testing that the API handles errors appropriately. Now that we've organized our requests, let's look at how collections can help us reuse configuration and test logic. Earlier, we talked about variables and environments. Collections can also have variables associated with them. This is useful when a group of requests share common values. For example, every request in our user API tests collection might use the same base URL. Instead of repeating that value in every request, we can use double curly braces base URL. Similarly, multiple requests might use the same user ID. Let's look at the collection's variable configuration. Now, any request inside this collection can reference these variables. One thing to keep in mind is that Postman supports variables at different levels. For example, we can have environment variables, collection variables, local variables, global variables. For today's presentation, the most important concept is simply that variables allow us to separate our test configuration from our request logic. The exact scope we choose depends on how broadly we want the variable to be available. Now let's look at the bigger picture and see how our collection has evolved from individual requests into a complete API test suite. Let's take a step back and look at what we've built. We started with individual API requests. We then added automated tests to those requests. We introduced variables so that our requests could be reused. We introduced environments so that our tests could work with different configurations. Now we've grouped our requests into a collection. Within that collection, we have organized requests into logical folders. We have tests for retrieving users. We have tests for creating, updating, and deleting users. We also have negative tests that verify how the API handles invalid requests. Our collection is now starting to look like a real API test suite. The important thing is that these aren't just random API requests. Each request has a specific purpose. Each request can have automated assertions. And the collection gives us a way to manage them as a group. Before we move on, I also want to mention one more useful feature. Because we've organized our requests into folders, we can run a specific group of requests. For example, I might want to test only the user retrieval functionality. Instead of running every request in the collection, I can run the relevant folder. Postman will execute the requests within that folder and run their associated tests. This is useful when we're working on a specific feature and want to quickly test only that part of the API. In the next and final section, we'll look at advanced API testing, chaining, test data, and automated execution. So far, we've treated our API requests as mostly independent, but real-world APIs often have dependencies between requests. For example, imagine we're testing a user management system. We might first need to create a user. The API responds with information about the newly created user, including a unique ID. We then want to retrieve that user. After that, we might update the user. Finally, we might delete the user. The problem is that we don't necessarily know the user's ID before we create them. This is where request chaining becomes useful. We can take information from the response of one request and use it in another request. For example, after creating a user, we can parse the response. We can then extract the ID returned by the API and save it as a collection variable. Now the next request can reference that variable. Postman will replace the variable with the actual ID returned from the previous request. This gives us a workflow that looks like create a user, capture the user ID, retrieve the user, update the user, delete the user. This is much closer to how we test real applications. The important idea is that the test data is generated dynamically. We're not manually entering IDs. We're allowing one API request to provide the information needed by another request. Once we have organized our API requests into collections, we don't necessarily want to execute every request manually. Postman provides the collection runner, which allows us to execute multiple requests in sequence. For example, we could run our entire user API test collection. Postman would execute the requests in the order we've defined. The tests associated with each request would run automatically, and we could review the results at the end. Another powerful feature is data-driven testing. Instead of testing our API with only one set of inputs, we can provide multiple sets of test data. For example, imagine we have a CSV file containing user ID and expected name. Our request can use user ID. For each iteration, Postman uses a different value from the data file. The first iteration might request user 1, the second iteration requests user 2, and so on. We can also access the current iteration's data in our test script. This means that one request and one test script can be executed against many different datasets. This is much more efficient than creating separate requests for every possible input. Data-driven testing is especially useful when testing different valid inputs, different invalid inputs, boundary values, large numbers of test cases. It also helps us avoid duplicating requests. Everything we've discussed so far can be performed manually through the Postman interface. But in a professional software development environment, we usually want testing to happen automatically. This is where CI/CD comes into the picture. CI stands for Continuous Integration. CD commonly refers to continuous delivery or continuous deployment. The basic idea is that when developers make changes to an application, automated processes can build the application and run tests. For example, we might have a pipeline that looks like this. A developer commits code, the CI/CD system starts the build, the application is built and deployed to a testing environment. Our Postman API tests are then executed. If the tests pass, the pipeline can continue. If critical tests fail, the pipeline can stop or notify the development team. Postman collections can also be executed outside the graphical Postman application. One commonly used command line tool for running Postman collections is Newman. This allows Postman tests to become part of an automated testing pipeline. For example, a GitHub Actions, Jenkins, GitLab CI, or Azure DevOps pipeline could execute the Newman command automatically. The overall workflow might be: developer commits code, the CI system starts, the application is deployed to a test environment, Newman runs the Postman collection, the test results are evaluated. If tests pass, the pipeline continues. If tests fail, the team is notified or the deployment is stopped. This is where API testing moves from being something that a developer runs manually to becoming an integrated part of the software development lifecycle. Let's quickly recap everything we've covered today. We started with the fundamentals of using Postman to interact with APIs. We learned how to create and send requests using common HTTP methods such as GET, POST, PUT, and DELETE. We then moved beyond simply sending requests and started writing automated tests. We used assertions to verify status codes, response data, data types, response structure, and response times. Next, we looked at variables and environments. These allow us to separate our API configuration from our test logic and make our requests reusable across different environments. We then organized our requests into collections and folders, allowing us to build structured and maintainable API test suites. From there, we explored more advanced concepts. Request chaining allows one API request to provide data to another. The collection runner allows us to execute multiple requests and tests together. Data-driven testing allows us to run the same tests against many different sets of input data. Finally, we discussed Newman and CI/CD. This is where Postman API testing becomes part of an automated software development workflow. The main takeaway I want you to remember is that Postman isn't simply a tool for manually sending API requests. It can be used to design, organize, execute, and automate API tests. We can start with a single request and a simple assertion and gradually build that into a complete automated API testing workflow. That workflow can eventually run automatically whenever developers make changes to an application. So, in a simplified form, our journey today has been send requests, validate responses, organize tests, parameterize tests, automate execution, and finally integrate with CI/CD. That's the core of API testing with Postman.